Okay, so let's do number 22 and 11.7, which says the population in a remote area has doubled in the last 18 years, and we want to approximate the annual growth. Okay? So what's the model for population growth? Good, it's this PERT thing, right? So P of T equals
P of 0 to raise the power of RT.
P at 0 e to the RT, right? Okay, so they want me to approximate the annual growth, and the annual growth is approximately this R, right? That's the growth rate. Okay, what's P0, what's T, what's E?
Initial amount is P.
Okay, P0 is the initial amount. What's T?
The time.
Time in some units, right? I kind of get to pick that. What's E?
The number.
Natural.
Yeah, E is the base of the natural logarithm. It's a number, right? So we don't need to do anything with the E's, right? That's already a number. Don't stick stuff in for that. All right, so what does my problem tell me about? What do they tell me the initial population?
No.
Oh.
It doubles in 18 years.
Okay, so P not, wait. P of 18, right? The population at time 18 is what?
3 times 2 P.
2 P0, right? Twice whatever it started with. Okay, what else is P of 18? Yeah, it's that thing with, you guys see that? It's that thing with a T equals 18 plugged in. You guys see that? So this is kind of, on the one hand, out of the problem, right? Like this bit is coming from this statement, doubled in the last 18 years, right? But then there's another way to figure out what that should be, and that's me taking my model, right? So P of 18 is also P naught e to the RT. Oh wait, I screwed something up. What is it? Yeah, the T is supposed to be 18 because I was trying to plug 18 into the model, right?
Why would it, I think I've already asked this question before, but why is it R when it's like that too? Because it doubles in like, but I know that.
You could set up a model, right? A different model with the 2.
But then it,
but then it would be a different model, right? Yeah, that you would use an exponent base of 2. We could figure that out, but it takes a little bit. Okay, so these two things should presumably be the same, right?
They're not? You set them equal to.
So why should these two things be the same?
Because you're using the same amount of time.
But you're using the 18.
So on the one hand, right, in 18 years, I know the population is double what it was.
Okay, so that's where we.
That's the top one. The other one is, from the model, the population should be something in 18 years, and it should be what I get when I plug 18 into the model, right? You guys see that? So this is like, on the one hand, the population is doubled. On the other hand, I have a model, so when I plug 18 in, I should get the answer. You guys see that? So these two things should be two different representations of the population at time 18.
So we're trying to find color.
So
Can we set them equal?
we're not trying to find P0, because we can't.
Because it wasn't given to you, right?
Yeah, because it wasn't given to us, and there's no information here that makes me think I should find P naught, right?
Oh, yeah. Okay, never mind.
But I should be able to find the annual growth rate, or at least approximately the growth rate, because that's R here. You guys see that? So if I write, kind of on the one hand, I have twice P naught, right? That's what they told me the population was in 18 years. And then I also have the answer my model gives, P naught e to the r times 18.
Oh, we can divide by P of 0.
You guys see that? We can divide by the P0, by the P naught. Because it doesn't matter, right? The population doubles. It doesn't matter how many you started with, it's still doubling.
It's a P naught.
Yeah, so we're dividing by P naught. And we get 2 is e to the 18r. Okay, now what would I like to do?
You want to get rid of the 2, so you're going to do a log. No.
I don't want to get rid of the 2.
You want to do the exponent of it, don't you?
I want to get the r down.
Yeah, so you want to.
You guys see that? R is what I'm looking for.
Get rid of the E then?
So we're dividing by E?
We're not going to divide by e because that's not. We're going to natural log both sides because we want the exponent down. And I have a base of e conveniently here. Now this isn't going to be really convenient because this side is 2, right? When I log that, I'm going to get log of 2, and it's not going to be super convenient.
Do you
Okay,
still
see
have
that?
to write log of 2?
Yeah, I still have to write log of 2. So when I ln both sides, right, that's natural logarithm. On the left, I'll get
Natural log of 2.
natural log of 2. And on the right, I'll get the exponent to the e, right? How many e's are present? That's 18 times r. Okay, now what do I do to solve for r? Divide by
2?
I would think
18. You want to get r by itself, right? So I want to get the coefficient off the r, so I divide by 18. So I get r is log of 2 over 18. Okay, to approximate, what's log of 2 over 18?
Approximately 0.0385.
No? How'd you pick I don't know, I think of log and I think 10.
So that's natural. This is natural log. The base 10 log is 10, right? That's the other one. That's log. There's actually lots, right? They're log base whatever. 2 of them got special names. Those were log base E and log base 10. So, on punching this into a calculator, when you punch this into a calculator, how do you do that?
I have 0.01.
Okay, there's an ln button, right?
Oh, I did the other one, sorry.
Would it be?
0.0385.
Okay, so when you push the ln button, right?
Yeah.
This comes up,
Yes. And then you enter 2 and the parentheses.
okay?
Do you press equal then divide by 18?
Either way.
Either way it'll come
Yeah,
out.
so-
0.038.
0.038.
It
5,
keeps
so
going.
39.
Well,
Cool.
yeah, it depends how you approximate first, because if you do natural log of 2 equals, and then divide the answer by 18, it's 0.0385. But if you natural log of 2 equals, and then you approximate it,
Oh,
and
yeah.
then divide it, then it's 0.03833.
Yeah, of course you can get some slight differences by where you're rounding, right? I would advise towards enter it all.
That's not what we got.
So you're pressing
Yeah, we
enter
did.
twice?
So it'd be-
Pressing enter once.
Oh, I thought.
That's what we got. It's the same thing.
Okay.
I just truncated early.
Okay.
Cool?
So.
So keep in mind that if you did this,
It'll come out different.
this will come out different. Because this is dividing the 2 by 18 and then taking the natural log of it. And what you mean to do is log the 2 first and then divide. You guys see that? The order here matters a lot. And your calculator puts this parenthesis in for a reason, so make sure you're closing it when you're done.
So when we do a log, is it automatically approximating, or is that just when it's,
When you punch it in the calculator, you're automatically approximating.
okay.
So there's a hard equal sign here, right? Log of 2 is actually a number, and divided by 18 is actually the R here.
Okay.
But if I want an approximation, I can stick it in the calculator and get this out.
Okay, so,
You guys cool with this?
Wait,
So the annual growth rate is approximately 0.0385 or whatever.
okay, so isn't that what we have to do, percentage or not? The annual growth rate sometimes. it's
Yeah,
like
so if they want a growth rate in a percentage, what's this growth rate as a percentage? 3.8%. Yeah.
Where should this count on this final? Should we write down the ln of 2 divided by 18, or should we?
I'm okay with either place. So on the final, if you want to stop at the hard equal sign and circle this, I'm okay with that. If you want to get an approximately, I'm okay with that.
So basically, if we forget our calculator, then we'll all be okay?
Yeah. Yeah, I've kind of been approaching this as you don't need a calculator. So in keeping with that, you don't need a calculator. Cool?
Might be nice to see